Hello everyone, today we'll present about our project's process and progress overview.
Hello everyone, I'm Tuan Minh, and today I will cover how we manage our Scrum process and how we handle the client requirements to meet the project goal. So now let me share with you our experience with the Scrum implementations and how it shaped our project's success. For the Scrum, throughout the project, we rotate the Scrum Master role each sprint to ensure everyone gains experience in leading the Scrum process. The Scrum Master for each sprint was shown as you can see in the slides. So that leads me to discuss how our Scrum meetings impact the project. Overall, our Scrum meetings prove instrumental in maintaining project alignment and momentum. They create a structured environment for efficient communications and prompt problem solving. Let me explain further why these meetings were successful. These meetings serve as a central forum for addressing both high-level goals and day-to-day challenges. We discuss everything from theoretical topics to practical issues. Notably, open communication lets us resolve blockers right away. If someone faces an issue, we brainstorm solutions together and assign follow-up tasks on the spot. Moreover, each team member provides an update on their work, which creates a rhythm of accountability and transparency. This kept everyone in the loop and helped prevent those gaps. Plus, if someone finished early, they could jump in to support others or take on new tasks. While we had many success, we also noticed two areas for future improvement. Firstly, I believe adding meeting recordings could be really valuable. This way, team members can go back to discussions, catch up on anything they missed, and review important points without needing to disrupt others or ask for summaries. Secondly, introduce time discussions would really optimize our meetings. For example, aiming to wrap up each topic in around 15 minutes can help us stay on track, cover everything on the agenda, and keep the meeting focused and efficient. Next, let me share how we structure our Scrum procedures. One of our key strengths was that we had a structured agenda, which kept discussion focused on our goals. Besides that, each Scrum Master encouraged participation, fostering open idea sharing. I remember in one session, a team member proposed an alternative feature session methods, and sparking valuable insight that significantly improved our final result. While these procedures work well, we also identify opportunities for future enhancement. We could design a priority flag system where team members can mark issues as high priority before the meeting. This will allow us to quickly identify and tackle the most critical challenge first, ensuring that we allocate sufficient time for them without disrupting the flow of the meeting. In terms of communications, effective communication was key to our success. Regular Scrum meetings kept us aligned and minimized misunderstandings, while a dedicated client feedback channel helped us quickly resolve ambiguities and adapt to changing requirements. These real-time communications support our agile approach and ensure we met the client expectations. So now, let me walk you through our requirement gathering process and how we manage changes throughout the project development. We took a methodical approach to gather requirements by splitting our 6-person team into 3 pairs, allowing us to divide and conquer while brainstorming and validating ideas together. Each pair focused on key areas like data pre-processing, model selections, and performance metrics covering all critical needs. Moreover, constant collaboration was key, with each page finding contributing to a clear, comprehensive view of our project requirements. Besides that, setting internal deadlines 3 days earlier gave us time for feedback and refinement, helping us define requirements quickly and accurately. This leads to an important question about our initial planning. As you can see, early requirement gathering was actually one of our key success factors. We established a clear roadmap from the start, ensuring everyone understood which methods and techniques we would implement. By front-loading our requirement gathering at the beginning of each sprint, we maintained a steady progress and kept everyone aligned with the project goals. However, even with initial planning, we did encounter some significant changes in requirements, particularly regarding our feature selection methods. As the project progressed and problem complexity increased, we discovered that our initial feature selection techniques weren't as effective as anticipated. This realization led us to search for 3 more robust methods. In terms of impacts, the requirement changes affect our timeline and workflow significantly, especially since feature selection was so essential. After investing time in the original methods, we now had to reallocate resources and adjust our schedule to maintain quality while adapting to the new requirements. While these changes present challenge, let me share with you how we transform this situation into an opportunity for improvement. We tackle these challenges collaboratively, starting with a team meeting to evaluate feature selection methods. These intense but productive discussions help us reach a consensus on new techniques to implement. We then adjust our timeline and reprioritize tasks, allow for extra research. This approach ultimately paid off with new methods significantly boosting our model performance. So now I'll pass to Phong to talk about the next section.
Our definition of done sets a structured framework to ensure each feature meets high standards in terms of functionality, accuracy, and usability. Initially, as the project progressed, we integrated more detailed criteria that emphasized model performance on the platform, ensuring alignment with real-world requirements. At the start, we have 4 different criteria. First, we have code completion, where code for each feature needed to be written, tested, and documented. Acceptance criteria, where each feature had to fulfill the specified user story. Basic testing and validation, where we have a basic unit testing for accuracy and basic integration testing. And documentation, where each code module required clear inline comments and an overview in the technical document. At first, that helped us a lot. But eventually, we have to develop and progress the definition themselves, and we have 4 different points. First, we have deployment and performance validation, where all components have to be deployed to Insight Factory for validation and performance metrics. Next, we have leaderboard submission and stakeholder approval, where we submit our best performing model to Insight Factory every 2 weeks. And we have a final sign-off from the client, confirm all features have met their requirements. We have advanced testing with the Insight Factory tools, where we use the integration tests and model performance checks there for larger scale testing and validation. And finally, we have detailed documentations and tracking with ML flow, which is self-explanatory. So how did our definition of done evolve, and why? So it evolved to integrate more advanced testing, deployment, and real-world validation criteria as we gain experience with this project requirements and the platform. So it effectively grew our understanding of predictive maintenance needs, the leaderboard's competitive standards, and our own commitment to deliver a reliable, high-performance solution. And it was essential due to the complex nature of predictive maintenance. As we tested initial models, we found that the simple accuracy metrics before was insufficient. So later on, as we evolve it, it has met industrial standards and ensured that our solution was not only functional, but competitive and reliable. So the justifications for our new definition of done is that it ensured high code quality and reliability, foundational for a predictive model deployed in a real-world maintenance context. Using the Insight Factory AI allowed us to achieve accurate and real-time validation. And finally, the leaderboard submission process verified our model performance relative to our peers to align our work with the competitive standards set by Insight Factory. So it helped us in developing a well-rounded and robust solution, meeting both project specifications and real-world predictive maintenance standards.
I'll walking through the tools and technologies we use for our railbreak projects. So there are a variety of tools that are carefully chosen for these projects, including Azure, Insight Factory, Git, and MLflow. So we're starting with the Azure first for data handling and management. It's used to process and manage our data efficiently. And with the integrations of Data Lake, it's ensure the ACID compliance, which comes in handy in managing data pipeline. And also for the model tracking, we use MLflow to track the model experiments and manage the version control, and this also allows us to roll back to the past versions when needed, so it's pretty handy. And for the deployment environment, we use Factory AI to streamline model production environments, which can facilitate very quickly and very reliable, so we can concentrate more on refining model instead of deploying. So for collaborations and CI/CD, we use Git as a primary version control tool to manage code change and enable the team to collab with each other and to merge and resolve conflicts. And also we use GitHub Actions to automate testing, deployment pipeline to accelerate the development process. And there's some tools we consider we didn't use, which is a TensorBoard to monitoring and visualizing the model performance, but we can't integrate it due to the compatibilities of the Azure notebook. And TensorBoard, with the TensorBoard, we could bring a better view of monitoring dynamics and perhaps having a better optimizations. So for the reflections and takeaway, it's very important to check the early compatibilities, so to make sure all tools work smoothly. And we need visual monitoring tools like Sensible to make things easier. And some takeaways could be like we can choose to prioritize the compatibility plannings and to focus on more client needs to align technical choices with the client requirements for usability and impact. So that's it for now. Thank you for listening to my part, and we'll get to the next part.
Testing approach. In our real break detection AI project, testing was crucial for ensuring model reliability and accuracy. While we didn't use test-driven development or TDD, we structured our testing to validate each pipeline component, from data preprocessing to model performance. For frameworks and testing methods, we used several testing frameworks specific to our tech stack. Scikit-learn tracked model performance through metrics like precision, recall, and F1 score. Imbalance learn helped validate data resampling, addressing data imbalances. MLflow tracked and version our model runs, allowing us to monitor changes and revert if needed. So why didn't we use TDD? Since requirements evolve frequently as new data and feature adjustments were added, TDD was not well suited for our workflow. Developing test cases early on would have led to frequent rework. Instead, we apply modular testing, especially for data processing script, testing components before integrating them into a larger pipeline. For adequacy of testing process, our testing covered critical areas, especially for model accuracy and data handling. MLflow version control helps us track changes and roll back when needed. However, high compute tasks sometimes cause interruptions, showing a need for a more resilient testing environment, like a dedicated cluster or automated resource checks. About opportunities for improvement. In hindsight, more integration testing before saving MLflows and automating validation would have caught issues earlier. While MLflow was useful for tracking, adding structured integration testing before version saving would enhance quality control. Overall, our testing effectively validated model performance, with MLflow being key for managing versions. Moving forward, we plan to add automated testing and stricter MLflow validation to ensure only thoroughly tested model advance the deployment.
Hello, so my name is Quang, and I'd like to provide an analysis of our overall progress. To start with, in terms of progress tracking, we use GitHub project board, both for user stories and acceptance criteria within each story, as in the task. Initially, we started a bit slowly as we had to get familiar with new tools. We also had to spend time with clarifying requirements and experimenting with different predictive model structures. And this was a bit time costly, but crucial for later stages. Tracking was initially sporadic as some team members forgot to update task statuses or record complete points consistently. Next, I'd like to mention impediments to our progress, and the main problem was with a steep learning curve with tools at the beginning, as I mentioned earlier. And this delayed our progress as we had to spend a lot of time for learning and experimenting with these tools before meaningful could be done for the project. And we had to refine and improve over time, especially in terms of task management. As we are more familiar with the data, we had to spend more time on pre-processing and model training. And then by mid-project, we implement a more focused review project so that key components can receive more consistent attention, and this helped with momentum for later stages. Communication was also streamlined by setting up dedicated channels for each task, which helped team members to stay up to date on progress and block tasks. Improved coordination allowed us to tackle dependencies and reduce bottlenecks. However, there were still opportunities for improvement. Firstly, in terms of task assignment, as for most of the time, we still assign tasks based on availability rather than strategic priority, which sometimes leads to delays in critical areas and over-allocated time for less impactful tasks. And a more priority-based task assignment will ensure that key components receive focused attention early for each sprint. And secondly, knowing the tools beforehand would be helpful as we can have less time for researching at the beginning. And finally, better documentation will help with onboarding and reference.
Hi, I'm Quoc, and I would like to share with you our team's approach to documentation. We created several key documents at the beginning of the project. We created an initial report to outline our objectives, project milestones, and key deliverables. When working on the project, we wrote comments within our code to explain functions, classes, and complex logic. The third one is weekly snapshots. This is where we documented our decision made and any issues discussed. Additionally, we wrote summarized changes made during the week and outlining plans for the upcoming one. We use GitHub's project board to manage user stories and tasks, moving them through stages like to do, in progress, or done. Each of us wrote a sprint retrospective to track individual progress, reflect on challenges, and identify areas for improvement. The final report, which is a comprehensive document summarizing our methodology and recommendation for future works. The snapshot and retrospective are intended for team members so that they can aware their responsibilities. The reports are meant for stakeholders, providing a detailed overview of our project's outcomes and contribution. The others are aimed at developers who might work on the project in the future for catching up quickly. We implemented several standards to maintain consistency and quality across all of our documentation. We suggested consistent formatting, which include a new form style guide, ensuring consistency in fonts, headings, and layouts. Practice agile method by using project board to manage tasks, making sure every member is catching up with the progress. And lastly, we perform reviews from time to time, about 2 or 3 times per week, to update documentation, especially after significant code changes. We implemented these standards to ensure clarity and ease of understanding for anyone interacting with our project, both now or in the future. Following industrial standard and agile methodologies, maintain a professional environment, and show our commitment to quality, which is crucial in any software development. Looking back, our project's documentation, I prefer 2 things. First is the use of GitHub project board. It provided a clear visual representation of our workflow, helping us track the progress of user stories. And the second is collaborative approach, where each team member actively contributed to the documentation. Personally, I think we still needed a little more documentation. We noticed that we didn't document our meeting minutes. This lack of formal records occasionally led to misunderstanding. We also realized that we missed out on comprehensive user guides for our end users. Without detailed instruction, they might find it challenging to navigate the software. Now, I would like to shift our focus on software analytics and discuss how certain development practices influence our code quality and project efficiency. There were circumstances that led to a better code. One factor that led to a better code quality was having reviewers who was already familiar with specific section of the code. There was one time when I was struggling with improving our data processing pipeline. Another member who had previously worked on it quickly spotted a potential performance bottleneck. They then suggested an optimization that improved efficiency. Their familiarity allowed them to catch subtle issues and ensure consistency within logic, which significantly enhanced our code quality and save us from potential problems down the line. If I had the opportunity to perform a data analytics on my project data, first, I will begin with a question: which environmental and operation factors most significantly contribute to the rail breakage within 60 days? The data that I needed would be historical rail break records, which are dates, times, and location of past breakage. The second is sensor data like rail stress levels, load weights, vibration, and track conditions. Third is environmental data, including temperature, humidity, precipitation, and fluctuation. Lastly, the maintenance history, such as dates and types of the past maintenance activities. What we would test is data pre-processing, which involves with cleaning and normalizing data, correlation analysis, where we identify relationship between factors and rail breaks. We will need to train machine learning models, algorithms to assess feature importance. And finally, we will use XAI methods like SHARP. The hypothesis we are testing is extreme temperature fluctuation and high rail stress from heavy loads significantly increase the risk of rail breakage within 60 days. That's all of my presentation. Thank you.
Finally, we have some final reflection on our entire process. First, we have some strengths. First, we have effective task division based on team strengths, where we allocate tasks according to each member's strengths. So someone with experience in ML can focus on model development and feature selection, while others can handle documentation and dataset processing. And this helped us have efficient progress in each sprint, allowing us to capitalize on individual strengths and ensuring high quality work. Next, we have improved communication and collaboration, where we have regular check-ins via virtual meetings, which help us keep everyone informed about our progress and any issues at all. This helps us facilitate smoother coordination, allowing us to address roadblocks swiftly and maintain alignment with project goals. Next, we have adaptability, where we for example, we encountered some computational slowdowns in Sprint 4 with SHAP and Lime. So to address it, we explored optimization options and adjusted our approach by focusing on interpreting only critical predictions, such as those near decision boundaries, and this adaptability allowed us to overcome technical challenges without sacrificing interpretability. Finally, we have documentation, because by Sprint 4, we have designated a team member for documentation to ensure that all comprehensive records of feature engineering, model tuning, and processing steps were made. So with thorough documentation, we prevented miscommunication and facilitated efficient task handovers, especially when working with complex modeling steps, and this strength contributed significantly to our project's sustainability and knowledge sharing. And next, we have some weaknesses. So first, we have some initial inefficiencies in meeting management. So in the earliest sprints, our meetings often lacked a structured agenda, leading to unfocused discussions and occasional overlap in task assignments. And it led to a lot of miscommunication redundancy, which slowed our momentum a lot. So for future projects, we plan to establish clear agendas and time limits for meetings and ensure discussions remain productive and on topic. Next, we have high computational costs, as we use techniques like SHAP and Lime, which added a significant computational load, particularly during visualization on large data set, which led to a lot of slowdowns during model evaluations in the Sprint 4 and 5. So it caused a lot of delays and limited our ability to experiment with alternative models in a timely manner. So later on, we would prioritize streamlining explainability methods using optimized libraries or focus on high-impact predictions to reduce the computational burden. Finally, we have some gaps in early documentation practices, as mentioned. We have in the initial sprints, we don't really have consistent documentation, leading to misunderstandings about certain steps in data preprocessing and feature engineering. And these gaps often cause delays as team members needed additional time to verify or repeat processes due to unclear instructions. So for future sprints, we would ensure that documentation standards are set from the outset, designating a dedicated role as we did to maintain detailed records across all project stages. And by addressing these, our group have learned valuable lessons that would enhance our effectiveness in future projects. The experience has also emphasized the importance of adaptability, clear communication, and structured workflows to achieve optimal outcomes in collaborative environments. Thank you all for listening.